All right, welcome year 10s to week 3. Today we are going to go through graphing functions. So we're going to look at how to do this on paper and how to do this on Excel. So resource checklist, make sure you've got your calculator, something to write on as well as something to write with. Grid paper would be really helpful in this case because we're graphing functions, but it's not necessary. Make sure you've got a good attitude as well. So just some visual cues as we're going through this PowerPoint. The pen symbol means I want you guys to write something down or work through some problems. The calculator symbol means you're going to have to use your calculator. You're going to do some working out. And the little laptop symbol means you're going to have to do something on your computer. Usually this is with Excel. Our WALT for this lesson is to represent linear and nonlinear functions on Cartesian planes. So what I want you guys to be looking for, what I would be looking for in your work, is appropriate axis size. So you're not having a gigantic y-axis and a tiny x-axis. You're going to correctly label every function in the axes every time. And you're going to use a table of values before you do any graphing. So those are the 3 things that I'm going to be looking for. I want you guys to look for in your answers. And why we do with graphing, why we do any of this with graphing is graphs show information in a very easy to read format, which is crucial for all walks of life. Because I guarantee you, all of you would have seen a graph when you look at the news, when you go look at stuff about your favorite video game. Whenever you look at something and look at some data, it's very often represented in a graph because that's very easy to read. So as usual, can you write down the WALT for this lesson? I want you guys to draw a fully labeled Cartesian plane with a domain from -5 to +5 in a range from -10 to +10. So what this means, on your x-axis go from -5 to +5 and your y-axis from -10 to +10. So just pause the video here and draw your Cartesian plane. So your Cartesian plane could look a little bit like this, with our x-axis starting at -5 and going all the way to +5, and our y-axis starting at -10 going all the way to +10. So you'll notice that I've labeled this the x-axis and this the y-axis. Now if you just want to put x and y, that is fine. And another thing that's not included on this graph, so I want you to think about that for a moment. What is not included on this plane? I haven't included arrows on my axes. So if you pick that up, well done. So this should be an arrowhead at the end of every axis to signify that it goes on forever. Our Cartesian plane doesn't stop it when we draw it. We've just only drawn it to there. So the Cartesian plane goes to infinity in every direction. Now I want you guys to start sketching some functions. So whenever we sketch a function, we're always going to start with a table of values. So we're going to include some negative, we're going to include 0, and we're going to include some positive numbers, so that we get a good idea, because interesting stuff happens around the 0. So I want you to sketch those 4 functions there. So this is actually the first question on the worksheet. So y equals 2 to the power of x minus 1. So this first function here is an exponential function. And then y equals x plus 5. So this is just a linear function. And y equals x squared minus 2. So this is a quadratic function. That's what these ones are called. And y equals -x squared plus 3. So this is another quadratic function. So the first thing I want you guys to do is make a table of values. So start with -3, -2, -1, 0, 1, 2, 3 for each function. So pause the video and do that now. This is what your table of values should look like for the first function and the second function. So pause the video and check. And this is what your table of values should look like for the third and fourth function. So once again, pause and check. And once you've done those table of values, you should have sketched them on the same graph. So we can see here that the blue line is our first function, our exponential. The orange line is our second function, our linear. The gray line is our first quadratic equation. And the yellow line is our second quadratic equation. So you can see on our graph there, these functions behave differently, even though we've used all the same x values. There are some points of intersection too, which is stuff we'll actually get into a bit later in the week and the unit. So now we're going to use Excel to graph a function. So the first thing I want you guys to do is set up your table something like this. Set up your spreadsheet something like this. So x values, y values, -10 all the way down to +10. So if you have to pause the video to do that, that's totally okay. So pause the video now, get your spreadsheet looking exactly like this. Now that you've done that, we're going to enter our function in. Now I've just written this stuff in so it looks a lot nicer. So in this cell here, I'm going to press equals. Then I'm going to click on the cell next to it. So my y value is using the corresponding x value. Then I'm going to press plus, and I'm going to press 5. Then I'm going to hit enter. So that cell should now read -5. So once again, press equals, I click on the cell next to it, I do a plus, a 5, I hit enter. Because that is our function for here, y equals x plus 5. So now I want to select this cell. You can see this little green square on the corner. So if we double click on that square, it automatically fills all the way down here using the values on the left. So that's pretty cool. So now I want to insert a graph, because that's what we're doing, the graphing. So I have to select both of these columns, all of this data. Then I'm going to go up here to insert. Then I'm going to move over to charts. I'm going to click this one on the bottom here. And I'm going to choose this, scatter with straight lines and markers. So this is my graph here. I'm just going to make it look a bit nicer by getting rid of that heading, make it a bit bigger. But there is our graph. So this is how you can graph using Excel. Now we're going to work on some problem solving, and we're going to be using graphing. So the concentration of alcohol in milligrams per liter in a bottle of champagne is modeled by this formula here, this function. C equals C0 times 0.33 to the power of KT, where this T here represents the time in days after the bottle has been opened. So if the initial concentration C0 is 80 milligrams per liter, and the concentration coefficient K is 0.1204, I want you guys to create a formula for the concentration C at any time T. So can you pause the video and do that now? And this is the equation that you should have. C equals 80 times 0.33 to the power of 0.1204 times T. Now I want you guys to create a table of values using the values 0, 1, 2, 3, 4, 5, 6, 7, 8 for T. So then I want you to graph the function from 0 to 8. So you're going to make a table of values with T and C and work out what your C values will be. Then I want you to use the graph to find the concentration after 3 days, after 1 week, and after 18 hours. So can you pause the video here and complete your table of values and your graph? This is what your table of values should look like. So really quickly, when I've got T equals 0, I've substituted in 0 here and gotten 80 as my answer for C. So when T is 1, I substituted in 1 and I get 70.00 and then some other numbers for my answer for C. So the important thing is that I'm substituting in correctly. So a scientific calculator will help. Make sure you're using your brackets correctly. And if you're a whiz at Excel, you can just use Excel to do this for you. But in any case, this is what your table of values should look like. So once you've done that, if you haven't done your graph just yet, can you pause the video and do your graph now? Now that we have got our graph, we can answer those 3 questions about what the concentration is at a certain point in time. So for that first question, what is the concentration after 3 days? Go up to 3, we go across. Well, we know this from our table of values anyway, and that is 53.6 milligrams per liter. Now after 7 days, so after a week, which is 7 days, we also got that value in our table of values, and that's 31.43 milligrams per liter. Now after 18 hours, so that's 3/4 of a day, so about here, you could measure exactly if you were using a hand-drawn graph, but if we're using a graph to get some information, we're only really estimating. So going up here, I'm going to say that's about 73 milligrams per liter. So that is my answer for after 18 hours, there will be 73 milligrams per liter. So that's the end of this lesson, graphing functions. So I want you guys to complete the graphing functions worksheet. Should be able to finish that, it's very straightforward. And then I want you guys to email me or use OneNote or Microsoft Teams for any questions you might have on the content in this presentation or any of the worksheet questions. And you can use Education Perfect as consolidation. So if you just don't get what I'm saying about a concept, have a look on Education Perfect. But that is not mandatory. That's an option for you guys to do if you want to do that. So happy studying.